Welcome to Management 3120's Chapter 5 lecture. This lecture will cover design of goods and services, and it's based on the textbook Operations Management, Sustainability, and Supply Chain Management, 12th edition, by Jay Heiser, Barry Renner, and Chuck Munson. So we're going to get started. So first we're going to cover our learning objectives. We're going to define product life cycle. Then we're going to describe a product development system. And then we're going to build a house of quality. And then we're going to explain how time-based competition is implemented by operations management. And continuing on, we're going to describe how goods and services are defined by operations management and describe the documents needed for production. We're going to explain how customers participate in the design and delivery services. And then we're going to apply to the decision tree the product issues. So firms must constantly be developing new products to become and remain industry leaders. Great products are the key to success. Anything less than an excellent product strategy can be devastating to a firm. And to maximize the potential for success, many companies focus on only a few products and then concentrate on those products. For instance, Honda's focus on its core competency, and that being its engines. Virtually all of Honda's sales, whether autos, motorcycles, generators, lawnmowers, they're all based on its outstanding engine technology. And likewise, Intel's focus on microprocessors. And then you have Michelin in the tire market. So here we have, organizations exist to provide goods or services to society. Great products are the key to success. And top organizations typically focus on core products. It just kind of used Honda as the example, as well as Michelin with the tires. Intel with the microprocessors. Customers buy satisfaction, not just as a physical good or a particular service. And fundamental to a organization strategy with implications throughout the operations function. Or because most products have a limited and even predictable life cycle, companies must constantly be looking for new products to design, develop, and take to the market. Operations managers insist on strong communications among customer, product, processes, and suppliers that results in a high success rate for their new products. It's limited and predictable life cycles requires constantly looking for and designing and developing new products. You always have to be on the move in this business. Utilize strong communication skills, like I said, among customer, product, processes, and suppliers, and new products generate substantial revenue. Now, leading companies generate a substantial portion of their sales from new products. Less than 5 years old. So we're going to go over this slide. The higher the percentage of sales from the last 5 years, the more likely a firm is to be a leader, as depicted here. And the importance of new products cannot be overestimated. As figure 5.1 shows, go right back here, leading companies generate a substantial portion of their sales from products less than 5 years old. And the need for new products is why Gillette developed its multi-blade razors in spite of continuing high sales of its phenomenally successful sensor razor, and why Disney continues to innovate with new rides and new parks, even though it's already the world's leading family entertainment company. Now, despite constant efforts to introduce viable new products, many new products fail. So product selection, definition, and design occur frequently. Now, perhaps hundreds of times for each financially successful product, operations managers and their organizations build cultures that accept risk and tolerate failure. That's safe to fail. That's being innovative. You can't span boundaries and be innovative unless you can tolerate some degree of failure. They learn to accommodate a high volume of new product ideas while maintaining the production activities to which they are already committed. I'm going to go back here. Now, although the term products often refers to tangible goods, it also refers to offerings by service organizations. Now, for instance, when Allstate Insurance offers a new homeowners policy, it is referred to as a product. Similarly, when Citicorp opens a new mortgage department, it offers a number of new mortgages, which is their products. And an effective product strategy likes product decisions with investment, market share, and product life cycle, and defines the breadth of the product line. Now, the objective of the product decision is to develop and implement a product strategy that meets the demands of the marketplace with a competitive advantage. As one of the 10 decisions of operations management that we covered, stemming all the way back to chapter 1, product strategy may focus on developing a competitive advantage via differentiation, low cost, rapid response, or a combination of these. So a world of options exist in the selection, definition, and design of products. Product selection is choosing the good or service to provide customers for clients. For instance, hospitals specialize in various types of patients and medical procedures. A hospital's management may decide to operate a general purpose hospital or a maternity hospital, or as in the case of the Canadian hospital, Shouldes, to specialize in hernias. Hospitals select their products when they decide what kind of hospital to be. Numerous other options exist for hospitals, just as they exist for Taco Bell and Toyota. Service organizations like Shouldes Hospital differentiate themselves through their product. Now, Shouldes differentiates itself by offering a distinctly unique and high-quality product. Its world-renowned specialization of hernia repair service is so effective it allows patients to return to normal living in 8 days as opposed to the average 2 weeks, and with very few complications. So the entire production system is designed for this one product. Local anesthetics are used. Patients enter and leave the operating room and on their own. Meals are served in common dining room, encouraging patients to get out of bed for meals and join fellow patients in the lounge. As Shouldes demonstrates, product selection affects the entire production system. Now, Taco Bell has developed and executed a low-cost strategy through product design. By designing a product, which is its menu, it can be produced with a minimum of labor in small kitchens. Taco Bell has developed a product line that is both low cost and high value. Successful product design has allowed Taco Bell to increase the food content of its products from 27 cents to 45 cents of each sales dollar. It's pretty significant. Now, Toyota's strategy is rapid response to changing consumer demand. By executing the fastest automobile design in the industry, Toyota has driven the speed of product development down to well under 2 years in the industry, whose standard is still over 2 years. Now, you think about this with strategic planning. I know whether we're talking about your intro course or some of the elements of this course, strategic planning is usually done in blocks of 3 to 5 years, or at least time horizons of 3 to 5 years. So think about what Toyota is dealing with, the turbulence of a volatile market. So their strategic planning in this area, has to be even quicker. It's probably 1 to 2 years. So think about that type of turbulence. And the shorter design time allows Toyota to get a car to the market before consumer tastes change, and do so with the latest technology and innovations. So product decisions are fundamental to an organization's strategy and have major implications throughout the operations function. Now, products are born, they live, and they die. They are cast aside by a changing society. It may be helpful to think of a product's life as divided into 4 phases. Now, those four phases are introduction, growth, maturity, and decline. Now, product life cycles may be a matter of a few days. For example, a concert t-shirt, months, and an example of that would be a season's fashion, or years. Like an example of that would be Madden NFL football video games. Or it could be decades. We could be talking about a Boeing 737. Regardless of the length of the cycle, the task for the operations manager is the same, and that is to design a system that helps introduce new products successfully. In the operations function, if they can't perform effectively at this stage, the firm may be saddled with loser products that cannot be produced efficiently, and perhaps not at all. And here in Figure 5.2, this slide depicts the 4 life cycle stages and the relationship of product sales, cash flow, and profit over the life cycle of a product. Now note that typically a firm has a negative cash flow while it develops a product, and that's a given. When the product is successful, those losses may be recovered, and eventually the successful product may yield a profit prior to its decline. However, the profile is fleeing, hence the constant demand for new products. Now, just as operations managers must be prepared to develop new products, they must also be prepared to develop strategies for new and exciting products. Now, periodic examination of products is appropriate because strategies change as products move through their life cycle. Now, successful product strategies require determining the best strategy for each product based on its position in the life cycle. A firm, therefore, identifies products or families of products and their position in the life cycle. Now, here we're going to start examining some strategy options as products move through their life cycle with the first phase, and this is the introductory phase. Now, because products in the introductory phase are still being fine-tuned for the market, as are their production techniques, they may warrant unusual expenditures for research, product development, process modification, and enhancement and supplier development. So, for example, when the iPhone was first introduced, the features desired by the public were still being determined. And at the same time, operations managers were still groping for the best manufacturing techniques. Now, in the growth phase, product design has begun to stabilize, and effective forecasting of capacity requirements is necessary. Now, adding capacity or enhancing existing capacity to accommodate the increase in product demand may be necessary at this point. And by the time a product is mature, competitors are established. So high volume, innovative production may be appropriate. Improved cost control, reduction in options, and a paring down of the product line may be effective or necessary for profitability and market share. And management may need to be ruthless with those products whose life cycle is at an end. So dying products are typically poor products in which to invest resources poor products in which to invest resources and managerial talent. So you don't want to waste your time and resources. Unless dying products make some unique contributions to the firm's reputation or its product line, or it can be sold with an unusually high contribution, their production should be terminated. And the effective operations manager selects items that show the great promise. Now, this is the Pareto principle applied to product mix. Resources are to be invested in the critical few and not the trivial many. Product may, by value analysis, list products in descending order of their individual dollar contribution to the firm, and it also lists the total annual dollar contribution of the product. So low contribution on a per unit basis by a particular product may look substantially different if it represents a large portion of the company's sales. Now, a product by value report, it allows the managers to evaluate possible strategies for each product. These may include increasing cash flow resulting from increasing contribution by raising selling price or lowering costs. Also, increasing market penetration resulting from improving quality, and or reducing cost or price or reducing costs. And that would be resulting from improving the production process. Improving that production process. If you remember Chapter 1 in productivity, reducing the costs up front, the input, will also increase productivity. So that kind of corresponds with this premise here. The report may also tell management which product offerings should be eliminated and which fail to justify further investment in research and development or capital equipment. So product by value analysis focuses attention on the strategic direction for each product. Now, because products die, because products must be weeded out and replaced, because firms generate most of their revenue and profit from new products, product selection, definition, and design take place on a continuing basis. It's highly iterative. So consider recent product changes, DVDs to video streaming, coffee shops to Starbucks lifestyle coffee, traveling circuses to Cirque du Soleil, landlines to cell phones, cell phone to smartphone, and then internet of digital information to an internet of things that connects you and your smartphone to your home, car, and even your doctor. And the list goes on. So knowing how to successfully find and develop new products is a requirement. It's an absolute necessity. So aggressive new product development requires that organizations build structures internally and they have, open communication with the customers. Innovative product development cultures, aggressive R&D, strong leadership, formal incentives and training. Only then can a firm profitably and energetically focus on specific opportunities. And these opportunities are the following, and it's depicted here on this slide. Understanding the customer is the premier issue in new product development. So many commercially important products are initially thought of and even prototyped by users rather than producers. So such products tend to be developed by lead users, and as companies, organizations, or individuals that are well ahead of the market trends and have needs that go far beyond those of the average user, the operations manager must be tuned in to the market, and particularly these innovative users. Now, next we have economic change, and that brings increasing levels of affluence in the long run, but economic cycles and price changes in the short run. In the long run, for instance, more and more people can afford automobiles. But in the short run, a recession may weaken the demand for automobiles. And number three, we have sociological and demographic change may appear in such factors as decreasing family size, preference for homes, apartments, and automobiles. And here, number four, we have technological change makes possible everything from smartphones to iPads to artificial hearts. Number five, you have political and legal change brings about new trade agreements, tariffs, and government requirement. Number six here, other changes may be brought about through market practice, professional standards, suppliers, distributors, so forth. The operations managers must be aware of these dynamics and be able to anticipate change in product opportunity, the products themselves, product volume, and product mix. So an effective product strategy links product decisions with other business functions, such as research and development, engineering, marketing, and finance. Now, a firm requires cash for product development and understanding of the marketplace and the necessary human talents. Now, the product development system may be well determined and may well determine not only product success, but also the firm's future. And here in figure 5.3 on this slide illustrates the stages of product development. Now, in this system, product options go through a series of steps, having each its own screening and evaluation criteria, but providing a continuing flow of information to prior steps. Now, optimum product development depends not only on support from other parts of the firm, but also on the successful integration of all 10 of the operations management decisions from product design to maintenance. Now, identifying products that appear likely to capture, market share, be cost effective and be profitable, but are in fact very difficult to produce, and they may lead to failure rather than success. Now, the quality function deployment, or the QFD, is the acronym, refers to both determining what will satisfy the customer and translating those customer desires into target design. The ideal is to capture a rich understanding of customers' wants and to identify alternative process solutions. Now, this information is then integrated into evolving product design. Now, quality function deployment is used early in the design process to help determine what will satisfy the customer and where to deploy quality efforts. Now, one of the tools of QFD, or quality function deployment, is the House of Quality, or the House Quality, a graphic technique for defining the relationship between customer desires and product or service. So only by defining this relationship in a rigorous way can managers design products and processes with features desired by customers. Now, defining this relationship is the first step in building a world-class production system. Now, to build the House of Quality, we perform these 7 basic steps. Now, first, we identify customer wants. That is, what do customers want in this product? Then we identify how the good/service will satisfy customer wants. That's identify specific product characteristics, features, or attributes, and show how they will satisfy those customer wants. Then the third one is to relate customer wants to the product house. That's to build a matrix that shows the relationships, 4, we're going to identify relationships between the firm's HALs, and that's how do our HALs tie together. Then we're going to develop importance ratings, and that's where we use the customer's importance ratings and weights for relationships in the matrix. And then we evaluate in number 6 here, competing products, and that's how well do competing products meet customers' wants. And then finally 7, we determine the desirable technical attributes, your performance and the competitor's performance against these attributes. Now, pursuant to the 7 basic steps we just went over, the following series of slides illustrate how to construct a house of quality. So we're going to use this example. Great Cameras Incorporated wants a methodology that strengthens its ability to meet customers' desires with its new digital cameras. So we're going to use the house of quality, or actually we're going to use the quality function deployment's house of quality with emphasis on the 7 basic steps that we went over. So first, through market research, Great Cameras Incorporated determined what the customer wants, and those wants are illustrated here on the left of the house of quality. It has to be lightweight, easy to use, reliable, easy to hold, steady, high resolution. Now, second, the product development team determined how the organization is going to translate those customer wants into product design and process attribute targets. These HALs are entered across the top portion of the house of quality. Now, third, the team evaluated each of the customer's wants against the HALs. In the relationship matrix of the house, the team evaluated how well its design meets the customer's needs. Fourth, the roof of the house indicates the relationship between the attributes. And fifth, the team developed importance ratings for its design attributes on the bottom of the table. Now, this was done by assigning values 5 for high, 3 for medium, and 1 for low to each entry in the relationship matrix, and then multiplying each of these values by the customer's importance rating. Now, the values in our importance ratings row, and that provides they provide a ranking of how to proceed product design, with the highest values being the most critical to a successful product. Now 6, the house of quality is also used for the evaluation of competitors. So the 2 columns on the right indicate how market research thinks competitors A and B satisfy customers' wants, good, fair, or poor. Products from other firms and even the proposed product can be added next to company B. Now, our seventh step here, the team identifies the technical attributes and evaluates how well Great Cameras Incorporated and its competitors address these attributes. Now, here the team decided on the noted technical attributes. Now, another use of quality function deployment is to show how the quality effort will be deployed. Now, as figure 5.4 illustrates, design characteristics of House 1 come to the inputs to House 2, which are satisfied by specific components of the product, and similarly, the concept is carried over to House 3, where the specific comments are to be satisfied through particular production processes, those particular production processes. So, once the production processes are defined, they become the requirements of House 4 to be satisfied. And here, this is figure 5.4 that we were just talking about, by a quality plan that will ensure conformance of those processes. Now, the quality plan is a set of specific tolerances, procedures, methods, and sampling techniques that will ensure the production process meets the customer requirements. So the QFD effort is devoted to meeting customers' requirements. The sequence of houses here is a very effective way of identifying, communicating, and deploying production resources. Now, in this way, we produce quality products. We meet customer requirements, and we win orders. So we see the correlation here of house 1, 2, 3, and then 4. Okay, so remember, house 1 come the inputs to the house, which are to house 2, which are satisfied by specific components of the product. And the concept is carried to house 3, where the specific comments are to be satisfied through particular production processes. And once those production processes are defined, they become requirements of house 4, where you see all the way to the right. Now, let's look at 4 approaches to organizing for product development. Okay, so we're going to get into organizing here. Now, first, the traditional U.S. approach to product development is an organization with distinct departments. A research and development department to do the necessary research, an engineering department to design the product, a manufacturing engineering department to design a product that can be produced, and a production department that produces the product. And the distinct advantage of this approach is that fixed duties and responsibilities exist. The distinct disadvantage is lack of forward thinking. How will downstream departments in the process deal with the concepts, ideas, and designs presented to them? And ultimately, what will the customer think of the product? A second and popular approach is to assign a product manager to champion the product through the product development system and related organizations. Now, a third and perhaps the best product development approach used in the United States seems to be the use of teams. Now, such teams are known variously as product development teams, designed for manufacturability teams, and value engineering teams. Now, the Japanese use a fourth approach. The bypass the team issue is by not subdividing organizations into research and development, engineering, production, and so forth. Now, consistent with the Japanese style of group effort and teamwork, these activities are all in one organization. So the Japanese culture and management style are more, collaborative, and the organization's a little less structured. It's less mechanistic than in most Western countries. Therefore, the Japanese find it unnecessary to have teams provide the necessary communication and coordination. Now, however, the typical Western style and the conventional wisdom is to use teams. Now, product development teams are charged with the responsibility of moving from market requirements for a product to achieving a product success. Now, such teams often include representatives from marketing, manufacturing, purchasing, quality assurance, and field service personnel. Now, many teams also include representatives from vendors. Regardless of the formal nature of the product development effort, research suggests that success is more likely in an open, highly participated environment where those with potential contributions are allowed to make them. And the objective of a product development team is to make the good service a success. And this includes marketability, manufacturability, and serviceability. Now, concurrent engineering implies speedier product development through simultaneous performance of the various stages of product development. Now, often the concept is expanded to include all elements of a product's lifestyle, from customer requirements to disposal and recycling. Concurrent engineering is facilitated by teams representing all affected areas, and these are known as cross-functional teams. So I know we've all heard of cross-functional teams. Highly, effective and very, very popular, especially with the projectize and matrix cultures that we've talked about. Now, manufacturability and value engineering activities are concerned with improvements of design and specifications at the research, development, design, and production stages of product development. In other words, design engineers should not just create a product that works, but they should also think about the product will be made and try to design it so that it is easy and cheap to manufacture. This slide identifies potential benefits that is as easy as cheap to manufacture as possible. So some of these benefits are reduced complexity of the product, reduction of environmental impact, additional standardization of components, improvement of functional aspects of the product, and improved job design and job safety, and improved maintainability, serviceability of the product, and a robust design. Now this slide, figure 5.5, provides an example of applying value engineering to bracket design. Each time the bracket is redesigned and simplified, the firm can produce it for less. So start to the left, you see it's very complex, a lot of parts there. And then look at the second example in the middle. Notice less parts, less money. And then finally we get to a very, very simple product to the right for significantly less than the first version. Now, in addition to developing an effective system and organization structure for product development, several considerations are important to design the product. This slide mentions some of the considerations. Now, first you have a robust design, modular design, computer-aided design / computer-aided manufacturing, otherwise both known as CAD and CAM. Virtual reality technology, value analysis, and sustainability life cycle assessment, otherwise known as LCA. Now, a robust design can be produced to requirements even with unfavorable conditions in the production process. No product is designed so that small variations in production or assembly do not adversely affect the product, and typically results in lower cost and higher quality. Now, a modular design has parts or components of a product that are subdivided into modules that are easily interchanged or replaced. Combinations of a few modules can produce a wide variety or final product configurations. Now, modular design helps firms implement postponement. Now, this slide describes computer-aided design, or CAD. Now, the use and variety of CAD software is extensive, and it's rapidly growing or expanding. The speed and ease with which sophisticated designs can be manipulated, analyzed, and modified with CAD makes review of numerous options possible before final comments are made. And this slide identifies several extensions of CAD. Now you have the 3D object modeling, small prototype development. You have design for manufacturing and assembly. DFMA is the acronym there. Solves manufacturing problems during the design stage. And then you have CAD through the internet, international data exchange through STEP, and 3D printing. Are all extensions of CAD. Now, computer-aided manufacturing, CAM, is the use of information technology to control machinery. So when CAD information is translated into instructions for CAM, the result of these two technologies is called CAD/CAM, CAD/CAM. And this slide identifies the benefits of CAD and CAM. CAD and CAM remove substantial detail work. It allows designers to concentrate on the conceptual and imaginative aspects of their task. It entails, results in product quality, shorter design time, production cost reductions, database availability, and new range of capabilities. Increases capes. And this slide describes virtual reality as a visual form of communication in which images substitute for reality and typically allow the user to respond interactively. So you have computer technology used to develop an interactive 3D model of a product from the basic CAD data. It allows, like I said, people to see the finished design before a physical model is built. It can save a lot of money for an organization. Also facilitate identifying flaws in the design, and very effective in large-scale designs such as a plant layout. Can't really build a prototype of a plant. You're going to build the plant. So virtual reality helps facilitating building the plant without building the plant, if you understand that. And this slide describes value analysis, which seeks improvements but takes place during, not before, the production process. So sometimes issues arise after production has begun that could not be anticipated ahead of time. Value analysis focuses on design improvement during production. It seeks improvements leading either to a better product or a product which can be produced more economically with less environmental impact. Now, sustainability and life cycle assessment, LCA, are two ways that managers can evaluate product options for product design. Now, customers are increasingly spending dollars on products of companies that strive to be environmentally friendly. Now, Supplement 5 in the text explores these issues in depth. Now, time-based competition referred here at the bottom, it refers to the developing products rapidly and moving them to market to gain competitive advantage. So it's about product life cycles, are becoming shorter and at the rate of technological change is increasing. We talked earlier about how Toyota deals with that with 2-year implementation. Measures, developing new products faster can result in that competitive advantage. Not all new products need to be produced from scratch, particularly when fast development speed is crucial. Other strategies may make more sense. Now, this slide, specifically figure 5.6 here, shows a continuum that goes from new, internally developed products over on the lower left to alliances on the upper right that cost, speed, and risk of product development all vary depending on the strategy chosen. Now, as product life cycles shorten, the need for faster development increases. And as technological sophistication of new products increases, so do the expense and risk. Now, for example, drug firms invest in an average of 12 to 15 years and over $1 billion before receiving regulatory approval for a new drug. And even then, only 1 of 5 will actually be a success. Those operations managers who master this art of product development continually gain on slower product developers. Now, to the swift goes the competitive advantage. Now, this concept is called time-based competition. That is competition based on time, rapidly developing products and moving them to market. Now, often the first company into production may have its product adopted for a use in a variety of applications that will generate sales for years. Now, it may become the standard, even. So consequently, there is often more concern with getting the product to market than with optimal product design or process efficiency. It's all about getting there quick. Even so, rapid introduction to the market may be good management because until competition begins to introduce copies or improved versions, the product can sometimes be priced high enough to justify somewhat inefficient product design and methods. Now, because time-based competition is so important, instead of developing new products from scratch, a number of other strategies can be used. And figure 5.6 here illustrates a continuum that goes on. It goes from new, internally developed products, over in the lower left, like we said earlier, to alliances, enhancements, and migrations used to the organization's existing product strengths for innovation and therefore are typically faster, while at the same time being less risky in developing entirely new products. One thing I want to make note of here is the product development strategies on the lower left of figure 5.6 here are internal development strategies, while the 3 approaches we now introduce can be thought of as external development strategies. So firms use both, and the external strategies are one, purchase the technology, and 2, to establish joint ventures. So the external strategies are to first purchase the technology, second to establish joint ventures, and the third is to develop alliances. Now, in respect to purchasing technology by an acquiring firm, Microsoft and Cisco systems are examples of companies on the cutting edge of technology that often speed development by acquiring entrepreneurial firms that have already developed the technology that fits their mission. The issue then becomes fitting the purchased organization, its technology, its product lines, and its culture into the buying firm, rather than a product development issue. So joint ventures here, in an effort to reduce the right of new cars, GM is in joint venture with Tokyo-based Teijin to bring lightweight carbon fiber to GM's customers. So joint ventures such as this one here are combined ownership, usually between 2 firms to form a new entity. And ownership can be 50-50, or one owner can assume a larger portion to ensure tighter control. And joint ventures are often appropriate for exploiting specific product opportunities that may not be central to the firm's mission. Now, such ventures are more likely to work when the risks are known and can be equitably shared. Now, when new products are central to the mission, but substantial resources are required and sizable risk is present, then alliances must be a good strategy for product development. And alliances are cooperative agreements that allow firms to remain independent but use complementing strengths to pursue strategies consistent with the individual missions. And alliances are particularly beneficial when the products to be developed also have technologies that are in ferment. For example, Microsoft is pursuing alliances with a variety of companies to deal with the convergence of computing, the internet, and television broadcasting. Alliances in this case are appropriate because technological unknowns and capital demands and risks, they're all significant. Now, once new goods or services are selected for introduction, they must be defined. Now, first, a good or service is defined in the terms of its functions. That is, what does it do? The product is then designed, and the firm determines how the functions are to be achieved. Management typically has a variety of options as to how a product should achieve its functional purpose. Now, for instance, when an alarm clock is produced, aspects of design such as the color, size, location of buttons may make substantial differences in ease of manufacture, quality, and market acceptance. Now, rigorous specifications of a product are necessary to ensure efficient production. Equipment layout and human resources cannot be determined until the product is defined, designed, and documented. Therefore, every organization needs documents to define its products. Now, this is true of everything from meat patties to cheese to computers to a medical procedure. Now, in the case of cheese, we just mentioned, written specification is typical. So, indeed, written specifications or standard grades exist and provide definition for many products. For example, Monterey Jack cheese has a written description that specifies the characteristics necessary for each department of agricultural grade. So it gets graded. Most manufacturing items, as well as their components, are defined by a drawing, usually referred to as an engineering drawing. An engineering drawing shows the dimensions, tolerances, materials, and finishes of a component. And the engineering drawing shows the dimensions, tolerances, materials, and the finishes. So, the engineering drawing will be an item on a bill of material, for example. The bill of material, the BOM, the bill of material. That's the acronym for it, BOM. That lists the hierarchy of components, their description, and the quantity of each required to make one unit of product. So an engineering drawing shows how to make one item on the bill of material. Now, just to expand a little on what we just covered, this slide shows a portion of the general requirements for the U.S. grades of Monterey Jack cheese. And here we have U.S. grade AA. Monterey cheese shall conform to the following requirements. Flavor is fine and highly pleasing, free from undesirable flavors or odors, and it may possess a very slight acid or feed flavor. And body and texture, a plug drawn from the cheese shall be reasonably firm. It shall have numerous small mechanical openings evenly distributed throughout the plug. It shall not possess sweet holes, yeast holes, or other gas holes. And just continuing with our example here, its color shall have a natural, uniform, bright, and attractive appearance, and finish and appearance shall be bandaged and paraffin dipped. And the rind shall be sound, firm, and smooth, providing a good protection to the cheese. So you never really thought how much goes into Monterey Jack cheese. Well, here you go. It's with every product. Now, two important product documents. Let's see. The engineering drawing and the bill of material. Here we have engineering drawing. That's shows dimensions, tolerances, and materials. It shows codes for group technology. And you have the bill of material. That lists components, quantities, and where used. Shows product structure. And here we figure 5.8 here. That provides an example of an engineering drawing. Just going to leave that up there for a minute. Figure 5.9 displays a bill of material for a manufactured item. Sub-assemblies and components are indented. And here we have a bill of material for a popular restaurant. Now, the make or buy decision, in some sense, must be undertaken for any products that a firm sells. Any of the components fit some sort of industry standard, and it often makes sense to purchase it from a supplier who has already gone through the full product development process. Make or buy approaches are very, very popular, even in project management. Do we want to, have things made for the project to save money, or is it beneficial to purchase? So, on the other hand, in-house production it can be cheaper, and in-house production can be cheaper in some cases. And the firm can exert more control when producing a product itself. Like I was just saying, especially this is very popular in project management. And, so this decision in make or buy, it's going to be discussed further. You're going to see this again in chapter 11 of the text. But it is definitely relevant to this chapter. So you want to pay attention to it. Now, the idea of group technology is to place products into families based on how they are manufactured rather than perhaps how they function or what they look like. Activities and machines can be grouped around these families. Therefore, you need to remember that group technology is a product and component coding system that specifies the size, shape, and type of processing. It allows similar products to be grouped. Now, as families of parts are identified, activities and machines can be grouped to minimize setups, routings, and material handling. An example of how families and parts may be grouped is illustrated here on this slide. Figure 5.10, 510. Group technology provides a systematic way to review a family of components to see if an existing component might suffice on a new project. Using existing or standard components eliminates all the costs connected with the design and development of the new part, which is a major cost reduction. And this slide illustrates some of the potential benefits of using group technology. You get improved design, reduced raw material and purchases, simplified production planning and control, improved layout, routing, and machine loading, reduced tooling, setup time, work in process, and production time. Now, once a product is selected, designed, and ready for production, production is assisted by a variety of documents. So now we'll cover some of these documents. Now, first we have an assembly drawing, and it simply shows an exploded view of the product. An assembly drawing is usually a three-dimensional drawing known as an isometric drawing, and the relative locations of components are drawn in relation to each other to show how to assemble the unit. Next, we have the assembly chart, and that shows in a schematic form how a product is assembled. Manufactured components, purchased components, or a combination of both may be shown on an assembly chart, and the assembly chart identifies the point of production at which components flow into subassemblies and ultimately into a final product. Now, the route sheets lists the operations necessary to produce the component with the material specified in the bill of material. And the route sheet for an item will have one entry for each operation to be performed on the item. Now, when route sheets include specific methods of operation and labor standards, they are often known as process sheets. And the work order is an instruction to make a given quantity of a particular item, usually a given schedule. The ticket that a waiter writes in your favorite restaurant is a work order. In a hospital or factory, the work order is a more formal document, and it provides authorization to draw items from inventory to perform various functions and to assign personnel to perform those functions. And in engineering, change notices here, the last one, ECNs, change some aspect of the product's definition or documentation, such as an engineering drawing or a bill of material. Now, for a complex product that has a long manufacturing cycle, such as a Boeing 777, the changes may be so numerous that no two 777s are built exactly alike, which is indeed the case. Now, such dynamic design change has fostered the development of a discipline known as configuration management, which is concerned with product identification, control, and documentation. Now, configuration management is the system by which a product's plan and changing configurations are accurately identified and for which control and accountability of change are maintained. So here we have an example of an assembly drawing that we mentioned earlier. Notice it is an exploded view of the product. And here we have an assembly chart. See how the components flow into sub-assemblies and final products. See the sub-assemblies there to the left, and they're kind of being bracketed into just the one final product. This slide provides an illustration of a route sheet. Notice the listing of operations necessary to produce a component with the material specified. And this slide depicts a work order. Notice it is an instruction to make a given quantity of a particular item. And here we have the engineering change notice, which is a correction or modification of an engineering drawing or bill of material. Now remember, configuration management is a system by which a product's planned and changing components are accurately identified. Product lifecycle management is an umbrella of software programs that attempts to bring together phases of product design and manufacture. The idea is that product design and manufacture decisions can be performed more creatively, faster, and even more economically when the data are integrated and consistent. Now, much of our lecture so far has focused on what we can call tangible products, that is goods. Now, on the other side of the product coin are, of course, services. Service industries include banking, finance, insurance, transportation, and communications. Now, the productions offered by service firms range from a medical procedure that leaves only the tiniest scar after an appendectomy to a shampoo and a cut at a hair salon, or to a great sandwich. Designing services is challenging because they have a unique characteristic, and that's customer interaction. And here in the process chain network, or the PCN is the acronym, analysis developed by Professor Scott Sampson, it focuses on ways in which processes can be designed to optimize the interaction between firms and their customers. So a process chain is a sequence of steps that accomplishes an activity, such as building a home, completing a tax return, since it's tax season, right? Or preparing a sandwich, as we said earlier. A process participant can be a manufacturer, a service provider, or a customer. And a network is a set of participants in this equation, right? So each participant has a process domain that includes a set of activities over which it has control. Now, remember, the process chain network analysis is an analysis that focuses in ways in which processes can be designed to optimize interaction between the firms and their customers, which brings us to this slide. And this slide depicts the PCN, the process chain network, for sandwich assembly, since we've brought that up as an example. So if you look close, the activities are organized into 3 process regions for each participant. Now, I know this slide could be a little bit of a challenging to focus in on or zoom in on, but try to do your best. So first, the direct interaction includes process steps that involve interaction between participants. Now, for example, a sandwich buyer directly interacts with employees of the sandwich shop, sandwich store. And the surrogate or substitute interaction region includes process steps in which one participant is acting on another participant's resources, such as their information, materials, or technologies. And this occurs when the sandwich supplier is making sandwiches in the restaurant kitchen. On the left side of the illustration of the slide, or alternately, when the customer has access to buffet ingredients and assembles the sandwich him or herself, which is illustrated on the right side here of the illustration. Under surrogate interaction, direct interaction is limited. Now, the independent processing region includes steps in which the sandwich supplier and or the sandwich customer is acting on resources where each has maximum control. Most make-to-stock production fits this region, which is depicted on the left side of the illustration. Think of the firm that assembles all those prepackaged sandwiches available in the vending machines and convenience stores. Now, similarly, those sandwiches built at home occur to the right in the customer's independent processing domain. Now, all three process regions have similar operating issues, them being quality control, facility location and layout, job design, inventory, and so on. But the appropriate way of handling the issues differs across regions. Now, service operations exist only within the area of direct and surrogate interaction. Now, from the operations manager's perspective, the valuable aspect of the process chain network, or PCN, analysis is insight to the aid and positioning and designing processes that can achieve strategic objectives. And a firm's operations are strategic in that they can define what type of business the firm is in and what value proposition it desires to provide its customers. For example, a firm may assume a low-cost strategy operating on the lift of figure 5.12 here as a manufacturer of pre-made sandwiches, and other firms such as Subway adopt a differentiation strategy. You remember differentiation from Chapter 2, with high customer interaction. And each of the process regions depicts a unique operational strategy. And just to revisit the process chain network analysis, its direct interaction region includes process steps that involve interaction between participants. The surrogate or substitute interaction region includes process steps in which one participant is acting on another participant's resources. And the third is the independent processing region, includes steps in which the supplier and or the customer is acting on resources where each has maximum control. And continuing with the process chain network analysis, all three regions have similar operating issues, but the appropriate way of handling the issues differs across regions. Service operations exist only within an area of direct and surrogate interaction, and the process chain network analysis provides insight to aid in positioning and designing processes that can achieve strategic objectives. Now, service productivity is notoriously low, in part because of customer involvement in the design or delivery of the service, or both. This complicates the product design challenge. We will now discuss a number of ways to increase service efficacy, and among these, several ways to limit this interaction. So first is limit the options. Because customers may participate in the design of the service, design specifications may take the form of everything from a manufacturer to list options for a funeral. To a verbal description at a hair salon. However, by providing a list of options in the case of a funeral, or a series of photographs in the case of a hairstyle, ambiguity may be reduced. And an early resolution of the product's definition can aid efficiency as well as aid in meeting the customer's expectations. So back to limit the options, again, because customers may participate in the design of service, Design specifications may take the form of everything from a list of options for a funeral, to a verbal description at a hair salon. However, by providing the list of options, back in the case of the funeral, or a series of photographs in the case of the hairstyle, ambiguity may be reduced. Next, you have delay customization, and the design of the product so that customization is delayed as late in the process as possible. And this is the way a hair salon operates. So although shampoo and conditioners are done in a standard way with a low-cost labor, the color and styling, that's the customization, are done last. It is also the way most restaurants operate. When you're asked, how would you like that cooked? Which dressing would you prefer on your salad? What temperature would you like your steak? Things like that. And then we go on to modularization, and that's to modularize the service so that customization takes the form of changing modules. So this strategy allows for custom services to be designed as standard modular entities. So just as modular design allows you to buy a high fidelity sound system with just the features you want, modular flexibility also lets you buy meals, clothes, and insurance on a mix and match basis. And then you have investments, portfolios, stocks, bonds, and education are an example of how a modular approach can be used to customize a service. Now you have automation. Divide the service into small parts and identify those parts that lend themselves to automation. Now, for instance, by isolating check cashing activity via ATM. Banks have been very effective at designing a product that both increases customer service and reduces costs. And similarly, airlines have moved to ticketless service via kiosks. A technique such as a kiosk reduces both costs and lines at the airports, thereby increasing customer satisfaction and providing a win-win product design. And then you have the moment of truth. And that's high customer interaction means that the service industry there is a moment of truth when the relationship between the provider and the customer is crucial. And at that moment, the customer satisfaction with the service is defined. And the moment of truth is the moment that exemplifies, enhances, or detracts from customers' expectations. And that moment may be as simple as a smile from an employee at Starbucks, or having a checkout clerk focus on you rather than talking over his or her shoulder at the clerk in the next counter. So moments of truth can occur when you order at McDonald's, you can get a haircut, or register for college courses. The operations manager's task is to identify moments of truth and design operations that meet or exceed customers' expectations. Now, because of the high customer interaction of most services, the documents for moving the product to production are different from those used in goods producing operations. And from example 2 in the text, this slide shows service documentation for a drive-up service teller window. So you have First Bank Corporation wants to ensure effective delivery of its service to its drive-up customers. That's the drive-through window, for drive-up customers. The approach is to develop a production document for the tellers at the drive-up window that provides the information necessary to do an effective job. So customers who use the drive-up teller windows rather than walk-in lobbies require a different customer relations technique. And the distance and machinery between the teller and the customer raises communication barriers. So guidelines to ensure good customer relations and drive-up window, they would be especially discreet when talking to the customer through the microphone. Provide written instructions for customers who fill out forms you provide. Mark the lines to be completed or attach a note with instructions. And always say please and thank you when speaking through the microphone. And establish eye contact with the customer if the distance allows it. And if a transaction requires that the customer park the car and come into the lobby, apologize for the inconvenience. So by providing documentation in the form of a script or guideline for the tellers, the likelihood of effective communication and good product or service is improved. Now, we spoke earlier, we touched on decision trees when we were going over the lesson. And here we are. Decision trees can be used for new product decisions as well as for a wide variety of other management problems when uncertainty is present. So they are particularly helpful when there are a series of decisions and various outcomes that lead to subsequent decisions followed by other outcomes. Now remember, a decision tree is a great tool for thinking through a problem. It can be used to help make a new product decision, especially when there are sequential decisions and outcomes. And to form a decision tree, we are using the following procedure. Okay? So first, we're going to be sure that all possible alternatives and states of nature, beginning on the left and moving right, are included in the tree. Now, this includes an alternative of doing nothing. Payoffs are entered at the end of the appropriate branch. And this is the place to develop the payoff of achieving this branch. And the objective is to determine the expected monetary value. Expected monetary value will be represented by the acronym EMV of each course of action. Now, we accomplish this by starting at the end of the tree, which is the right side, and working toward the beginning of the tree, which is the left side, calculating values at each step and pruning alternatives that are not as good as others from the same node. So now we're going to examine a decision tree applied to product design. Now in this example, Silicon Incorporated, a semiconductor manufacturer, is investigating the possibility of producing and marketing a microprocessor. Now, undertaking this project will require either purchasing a sophisticated CAD system or hiring and training several additional engineers. Now, the market for the product could be either favorable or unfavorable. And Silicon Incorporated, of course, has the option of not developing the new product at all. Remember, kind of like corresponds with the make or buy. So that is an option, is that you're either going to develop or it's not prudent or cost effective to develop. Now, with favorable acceptance by the market, sales would be 25,000 processors selling for $100 each. Where you see at the top there to the right in the revenue, 2,500,000. With unfavorable acceptance, sales would only be 8,000 processors selling for $100 each. So if you look underneath at the low sales, that revenue would be represented by the $800,000 there. Now the cost of CAD equipment is $500,000, but that of hiring and training 3 new engineers is only $375,000. However, manufacturing costs can drop from $50 each when manufacturing without CAD to $40 each when manufacturing with CAD. So the probability of favorable acceptance of the new microprocessor is 0.40, okay? And the probability of unfavorable acceptance is 0.60. So it is apparent that the use of a decision tree is appropriate, as Silicon Incorporated has the basic ingredients: a choice of decisions, probabilities, and payoffs. So the probabilities here have been fed to us, okay? So here we draw a decision tree with a branch for each of the 3 decisions and assign the respective probabilities and payoff for each branch, and then compute the respective EMVs, okay? So the expected monetary value, EMV, has been circled at each step of the decision tree for the top branch, okay? So here we have the formula. So you have your expected monetary value, which is purchase CAD system, and it equals 0.4 times 1 million plus 0.6 times negative 20,000. In that case, you're going to get $388,000, as you see there. Right there. Now, this figure represents the results that will occur if Silicon Incorporated purchases the CAD. And we're going to move on. And we're going to calculate the expected value of hiring and training engineers, which will be the second series of branches on the decision tree. Okay, so we have the expected monetary values being hire or train or trained engineers, or hire and train the engineers rather. And so we have 0.4 times, we're doing the same thing essentially here. We're just going to do a comparison afterwards. 875,000 plus 0.6 times 25,000. And that comes out to 365,000. Now, because the top branch has the highest monetary value, which is an expected monetary value of $388,000, and that's versus the $365,000 in the next one down, and that was representing the hire and training engineers, and that is versus doing nothing at 0. So because it's the highest, $388,000 is the highest number at the at the top branch. It represents the best decision. Therefore, management should purchase the CAD system. Use of the decision tree here, in this case, provided both objectivity and structure to our analysis of the Silicon Incorporated decision. Now, as a firm can tinker indefinitely with a product in search of improvement, one of the arts of management is knowing when a product should move from development to production. Now, eventually, a product, whether a good service, has been selected, designed, and defined. It has progressed from an idea to a functional definition, and then perhaps to a design. Now, management must make a decision as to further development and production or termination of the product idea. Now, the product development staff is always interested in making improvements in a product. And because this staff tends to see product development as evolutionary, they may never have a complete product, but as we noted earlier, the cost of late product introduction is high. Now, although these conflicting pressures exist, management must make a decision: more development or more production. Now, once this decision is made, whether we're going to more development or more production, there's usually a period of trial production to ensure the design is indeed producible. And this is the manufacturability test. So this trial also gives the operations staff the opportunity to develop proper tooling, quality control procedures, and train personnel to ensure that production can be initiated successfully. Now, finally, when the product is deemed both marketable and producible, line management will assume responsibility. And to ensure the transition from development to production is successful, some companies appoint a project manager. Others use product development teams. Both approaches allow a wide range of resources and talents to be brought to bear to ensure satisfactory production of a product is still in flux. And a third approach is integration of the product development and manufacturing organizations. And this approach allows for easy shifting of resources between the two organizations as needs change. Now, the operations manager's job is to make the transition from research and development, or otherwise known as R&D, to production. It's the operations manager's job to make it seamless, in other words. And this concludes the Chapter 5 lecture. Please check all the expectations and deliverables associated with this chapter, and I will see you in Chapter 6.